I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
Alright, this video is an introduction to functions. Here are 4 vocabulary words that you need to know: relation, function, domain, and range. I'll be using these words and I'll expect that you have them in your notebook. A relation is a set of ordered pairs. An ordered pair is an x value and a y value. That's an ordered pair. A function is a special type of relation that pairs each domain value with exactly one range value. Domain is the set of x values in a relation, and range is the set of y values in a relation. So there's multiple ways that we can represent relations. So we're going to look at them. So the first example here is ordered pairs. So I have a list of ordered pairs, which is 6, -1, 5, 0, 2, -4, and 1, 0. So I have 4 ordered pairs there. That is a relation. Now I could put that in a table. So if I wanted to make a table, I would have an x column and a y column. The x value of the first coordinate is 6. The y value is -1. The next is 5 and 0, 2, -4, and 1, 0. So there are my 4 points represented in a table. I could also represent them on a graph. So I could plot these points on the graph. 6, -1 would be right about here. 5, 0 would be here. 2, -4 would be here. And 1, 0 would be here. So that is the relation represented on a graph. So as I'm going through these, you should be able to go between representations. What I mean by that is, if I give you a table, you should then be able to write the list of ordered pairs or put it on a graph. And that should go both ways. Given any representation, you should be able to come up with the other representations. So lastly, let's look at a mapping. So in a mapping, you have sort of these 2 ovals. The left oval represents x, the right oval represents y. And what we're going to do is we are going to map the x value to the appropriate y value. So here are my x values and my y values. Now if you'll notice, I have 4 x values but only 3 y values. That's because the 0 repeats. So my 6 maps with my -1. So I'm going to draw an arrow from 6 to -1. My 5 maps to 0. My 2 maps to -4. And my 1 also maps to 0. So that is what my mapping would look like. So looking at these 4 examples, again, given any representation, you should be able to come up with the other 3. A function, remember, is a special type of relation that pairs each domain value with exactly one range value. What that means is that each input, or the domain, the value of the domain, has exactly one output, which is the range. So we're going to look at some examples and determine if they are a function or not. Remember, a function is a relation. So all of these are relations. We're trying to determine if it's a function, which is a special type of relation. So looking at the first example, we have -3, 5, -5, 3, -7, 1, and -9, 3. So does each input have exactly one output? So for the input -3, the output is 5. If I look at the table, I do not see another input of -3. So that looks good. When I input -5, I get out 3. When I input -7, I get out 1. And when I input -9, I get out 3. So it looks like for each of these, there is only one output. So this would be a function. Now let's look at a mapping example. So again, this is input and this is output, or x and y. So does each input have exactly one output? Well, the 0 maps to the -4. So what I'm going to do, I prefer to see things in a table. So I'm going to go ahead and make a table for this. So 0 goes to -4. 1 goes to -2, 2 goes to -4, 2 also goes to -5, and 3 goes to -2. So what I notice here is I notice that the input of 2 has 2 different outputs. So when I plug in a 2, I could either get -4 Or when I plug in a 2, maybe I get -5. Therefore, this is not a function because each input does not have its own output. It does not have only one output. So if you noticed in our first example here, there were 2 3s in the output, whereas in this example, there were 2 2s in the input. So if the output repeats, it is okay. But if the input repeats, it is not okay. It would not be a function. Our last example here is a graph. And so we're determining if this relation is a function. And I don't really see any points here, but there are points all over this line. Okay, there's an infinite number of points. And so what I want to think about is, given, these points that I'm thinking about, does each x value have just one y value? So let's take this point for example. Let's say that's at -1. So for -1 on the x, what is the y value? Well, it's this, which is, we'll say 1, right? So for -1, the y value is 1. But if I go up here, for -1, the y value may also be 5. So I'm looking at these 2 points, and it's looking like this one input right here has actually 3 different outputs. So this is not a function. In fact, when you're looking at a graph, you can do what is called the vertical line test. With the vertical line test, basically what you need to think about is, if you draw a vertical line through the relation, if that vertical line touches the relation more than once, then it is not a function. And so I could also draw a vertical line here, and again, it touches 1, 2, 3 times. So that is not a function, and we can use the vertical line test for that.
I've been waiting way too long. Yeah, I've been